Good day, YouTube. Showing off my adorable kittens. And so that one's name is Hope. That one's name is Aries. And that's my grandpa's flight suit, active duty Navy for 25 years as a test pilot. And then what I got going is this ground wire here. And the ground wire goes to this brass fitting in here, right there. And basically that's the inlet to this water, so that it's basically connected to the water, as you can see. If I follow this back, I tucked it in right here, so it's like easy enough to see basically, but so I don't trip on it as much. But I wanted to not fully tuck it in so that you can see it and follow it. So there it is, going out like this. Don't mind the cord, it's not actually live right now. I only use it from these inverters when I need to. You know, not unnecessary fire danger risk, right? So what I got here is this green LED lit right off of that, which is pretty cool. And so this is a 1000 ohm resistor right there. And then this is a diode, this type, this Scotchy diode 1N5819. And as you can see, I have the wire not even connected directly. I just have it through this water here. And I added a pinch of salt as well as some activated carbon. And so I'll show you what that is right here. So this is the activated carbon. Turn on the brightness. Okay, so move it into the light, I guess, because I turned on the light, but it's not bright in here at all. So it's this Filtrazorb 200 activated carbon, medium grain size. It's like the stuff you get to like filter your aquarium with. When I put it in here, it like fizzed, which was kind of cool. So it's not the chemistry doing it, by the way. It's not like a little, well, maybe it is acting like a little battery, but it's not like the battery powering it, because you've seen me do this. So for another demonstration purpose, I have more ready here. So basically, as you can see, cathode on this side of the LED, and then I can touch it to this, and you will see, if I can grab it, see that? So it's flickering just because it's not good contact. There we go. So and then you can see with a resistor with no diode, and then you can see I had more here, I thought. Oh yeah, here's the reversal diode one. So see how the diode is going backwards? So it still lights up, but it's not as bright on this version. Actually, it does look about just as bright right now. Kind of depends on the angle. It's hard to tell. Seems like previously wasn't as bright, but now it seems to be plenty bright with it going both directions, which is kind of cool. And then, so let's do a red LED, and I didn't attach anything to it, I just kind of grabbed it. You can see the red LED lights as well. What other colors I got here? I think these are like different somehow. I don't remember what exactly these are. Hello YouTube. So what I got here is a little bit of the rainbow. First we'll start at the lower frequency with red, and we'll see if that lights. And sure enough, we can see that it does. And then we have another red here, which I have hooked up, and you can can see that that lights up. This red bulb lights up even better. And then this one really lights up. So we got the low frequency covered here. And then for whatever reason, this yellow bulb doesn't light up so well, so I didn't put any resistor on it. But as you can see, it does light up just a tad. And then I don't really see this guy, this orange bulb, lighting up at all, but maybe you can tell me if you see it. So, sorry for my filming. Yeah, I don't see any light from this orange one, but as you know already, this green bulb lights up. This is attached to the water table essentially and being powered by the water. And the water, well, it's not really the water, it's the solar energy, the etheric pressure, if you will, the scalar waves going through the water. Anyways, so as you can see, it's connected into this cup through water, and this wire, as you know, is going to the water pipes. And so it also works still through my body. Green works good. The brightness kind of depends on the angle here a little bit too. But it seems to work better with my body. Like, my body is almost like brighter than this thing, which is pretty wild. And then to tap it off, as you can see, we got some blue here. Blue, higher quantization energy, no problem. Lights right up, super bright if I get the right angle, as you can see. So yeah, pretty cool. Let's go outside and see if it works in some water. So inside with water running, and as you can see, does not light up. Does not light up. So kind of interesting. So as you can see, I touch it into the water and no light. So, you know, it's still safe and everything for everyone. And I touched various objects around the house and outside to make sure too. What's cool is that it even lights up this ultraviolet bulb. Check that out. I don't know if it's sensitive enough with the camera. You can see it get slightly brighter. So yeah. So it's pretty bright just connecting to the water pipe, but look how much brighter it is touching it. So I made this little thing so that I could plug in multiple different colors at once. Since I showed each color individually lighting up, I wanted to just make an indicator of all of them at the same time. And when I go and touch this to this, it gets dimmer. And the red one you can see is YouTube. So what I got here is a 144 watt inverter powering my phone, which is at 6% battery with this 15 watt like charger. And then we got a 140 watt fan that's running on low speed. And then we also have a LED light, all being powered by that. So in theory, it's being pushed over its limit and it has no problem. And it's because of that little super cap bank right there behind that battery, that red lead. And I also want to show you something interesting. So I was showing you guys those LEDs earlier and my phone died. So I had to continue on experimenting and get things ready for the next part of the video. So I thought like all colors would work, but they don't all work at once. kind of weird. Like the blue one kind of lit up there. Trying to find it. Seems to not light very well. You see kind of like a flash of a forward voltage, but it doesn't really like... Sorry, I gotta edit that out. So I guess the red and the blue kind of light up when you touch it, but they don't light up together. And the green lights up the best, and they light up together well. So what I have here is basically diodes going into a cup of water, and as you can see, the diodes are in the direction, so it can't come from the battery. And you know, maybe some current is leaking through those diodes, and but it shouldn't be going that way. It's like, you know, because this is the cathode side. But I guess negative flows to positive, right? So maybe it is leaking out, but I believe it's the scalar fields because that's not normal. And what I have here to show you basically is that this cup, like I was saying earlier, with this line is connected to the water ground line. And then I have this wet like towel thing on the concrete. And so basically, if this is in, it's very bright like this. And if I pull this out, so I'm going to slowly pull this out, try to get it all in view. See that? See how much it dims? But it's still going. You can definitely see, especially if I get the right angle to where you can kind of see down it. But as soon as I touch this, for example, definitely gets brighter on even both of them. Isn't that weird? Pretty cool. And then also, just putting this back in, you can see it get brighter again. So pretty cool effect. And so I have the ground lead in here, and we're on 50 volts DC here. And I'm just gonna touch this. So that, and now I'm gonna just stand up. Here, I'll take this with me. The lead doesn't go very far, but standing seems to be about the same. And when I touch this as well, you can see it go down. So that's me touching the wet towel next to me versus me on the ground. So that's because my relative ground is equalizing with that more, and so I'm less positive relative to it. Kind of cool. So yeah, that's kind of how scalar waves behave, and that's why you have to be careful with it. When I was plugging a plug-in over here, I felt a little static pressure and a tiny little arc discharge off of ground pipe over there, and it is grounded very well, and the solar panels are quite literally on the ground and grounded as well. So I know things are safe at this point because I've tested things with multimeters and whatnot, but as far as your body goes, like you would definitely not want to touch across this ground of the potentiometer and that ground with your right and left hand, for example. That would be a definite no-no. But yeah, just wanted to show you something interesting. Yeah, that's just me on my finger. So also, if I pull this out now, look at all those bubbles. All these little tiny bubbles. Especially on the wire. So I guess the one with more bubbles on that side is the hydrogen side, and this one with less bubbles is the oxygen side. So I've yet to kind of figure that out, but if I measure this with a multimeter, it should go pretty easy, right? So what we'll do is we'll go, I guess, we'll go right here, and then the positive will go up here. So I think it's a reverse polarity, which makes sense. So positive in the water, and then yeah, so positive in the water, and then touching the ground, it goes up slightly. So when I touch this, you can see the lights go out, but you can also see that it's measuring energy there. Maybe this will blow my fuse on milliamps, maybe it won't, I don't know. But yeah, as you can see, we don't measure any current, so that's proving that it's actually displacement current, scalar wave collapse, and not just, you know, like reversing through here with leakage somehow. It's a little bit different than that. It's like the scalar wave can phase shift and collapse into real usable energy with the light emitting diode. Similar to how the scalar wave can collapse and whatnot in the layers of the solar panel. And so, yeah, hopefully we can create standing or at least resonating scalar waves with these batteries to kind of create a ground pump effect and replenish them with less solar panels, or maybe even no solar panels. But the solar panels is obviously a it's affected by scalar waves. So if you build pressure inside of them, you can get them to run for longer, seize more voltage and more scalar electromagnetic photon pressure to create those electron pairs. And the graphene supercapacitors are really good wells for that scalar pressure, the reservoirs, because it's like a broadband energy acceptor, if you will. And then you combine that with maybe some multiple waves, higher frequencies, with some lower frequencies, and then you like don't convert it into like any heat until you get to like that stage, for example. So yeah,